All right, so this video is going to cover this AP Computer Science Principle String Practice Quiz number 1. Okay, so let's go through this. So Yelp provides a restaurant search feature on their website. Okay, so there's their website. The code to display the search filter and results relies on many variables. Which of these variables are storing a string data type? Note there that there may be multiple answers. Okay, cool. So strings are anything stored in quotes. So A is one because that's sushi is stored in a quote. And if you look at it, you know, that's where that would be right here. Category. So where's the category at? So that would be Japanese right there. That would be a string. Near. Search near. I don't see where that is, but anyway, it's in quotes, so that's circled. Now, this is a number right here, and it looks like an integer, but it's still a string because it's in quotes. And the last two are also in quotes. Sort by, which is what? Sort by, I see sort by, but I don't see closest. Yeah, I don't see it. And then state, I'm not sure I saw the state on there either. Either way, well, there's the best results, but up here there's a state. And there's that. So anyway, these are all in quotes, so those are all strings. Now, why would you have something like this? Well, this looks like a zip code to me, but I'm pretty sure I'm not pretty sure, I'm positive I've seen zip codes that are like 5 numbers, like 1, 2, 3, 4, 5, and then they have a dash like 1, 2, 3 next to them. And we're seeing more of this as more, small cities, I think, more areas are growing in the nation, more people are living in different places, and so they need different zip codes. So anyway, because there's a dash in there, they have to put that in a string and store it as a string because it's no longer an integer. So I think that's what they do. They just put it in this quotes. So 2 says the following variables are from a family tree program. Identify which variables store numbers and which store strings. So that's a number, that's a number, it's a string, that's a string, and that's a number. Again, strings are in quotes. Numbers don't have quotes around them. Okay, 3. Isabel is programming an app called Plant Watch, which lets users monitor the health of their plants. Which variables would she most likely use a string data type for? So num leaves and acidity, moisture. So this would be like a double. Acidity would probably be an int. Num leaves is probably an int. I like using red. I don't know why I just switched that to black. Height, the height of the plant in centimeters is probably an int. Species, the name of the species, that's clearly, so the species would be like, I don't know, a plant species. I don't know, dandelion. I don't know plant species, but I know that dandelion would be the name of it, and that would be stored in a string. So E is clearly your answer, okay? like how that. Okay, 4. Assume that assume that the substring AB command can be used to produce a substring of a string where A is the index of the first letter in the substring and B is the index of the last letter in the string. Also assume that the index of the first letter in a string is 1. Okay, so anytime you have a string, your string right here, my good opinion once lost is forever. So, let me write this out a little bit bigger. So my good OP, I don't know if I'm going to be able to get the whole thing in. Let's just say opinion. Okay, that's fine. That's plenty. Because this is hard to write in, and I'm trying to make this a little bit bigger for you guys. So strings, each character of a string has an index position starting. In this class, we start at position 1, even though in real Java you start at position 0. One, 2, 3, 4, 5. It's a 4. All right, so if we have 4 to 7, what that does is that pulls out GOOD and it stores it in Q. So that's where good displays. Okay, so next one. Also assume that join A to B command can be used to join several strings together. So if we join those two together, we would get Mr. Darcy. Now there's no space in there, okay? Okay, and then they show that right there, all right? So we're combining these together with a join method. Also assume that the length of this, so if we have the string Elizabeth, okay, the length is 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 characters in there, so the length is 9, okay? After the above code segment, Y would be set to 9 because they're, okay, which of the following would set Z to an even number? I'm going to have to zoom out here. Okay, because I've got a... let's do this, zoom a little bit. See if I can get all this on one page. Okay, cool. So substring. Okay, so what I'm going to do here again is I'm going to write out that my good. And it looks like I'm just doing this because I'm not doing the whole thing because just glanced at it. It doesn't look like we're going to use the whole. All right, so substring 1 to 3. 1 to 3 is, oh shoot, I screwed this up again. Whoops. Okay, what I did there was I started at position 0. Start at position 1. okay, nothing's in position. Nothing's there. All right, so yeah. So again, on AP tests, you always start position 1. So we want a substring 1 to 3. So 1 to 3 is, whoops, and I even screwed this up. Dang it. Sorry again. Making easy mistakes here because I'm trying to go too fast. Okay, so that's there. There's space in between the word my and good. And I need to account for that. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5. Okay, that's better. So 1 to 3 is, for this one, my space. Now I'm going to use an underscore for a space even though there's no underscore there. Then we want to do the length of the substring. Well, wait, we want to do the length of this is 1, 2, 3. So that would be 3 right there. 3 plus, and then 5 to 8 is O. So it's like plussing O, D space. So it's 1, 2, 3, 4. So 1, 2, 3, 4. 3 plus 4 is 7. So what are we trying to do here? Which of the following would set Z to an even number? So this sets it to 7. So A is not correct. Okay. So this one we want to do 1 to 12. So 1 to 12 would be what? 1 to 12 gives us our substring, and then we need to do 1 to 7 as our substring, then we join those. So 1 to 12 gives us my space good space O P I N. O-P-I-N, that's 12, okay? And then we're going to join these two together. So 1 to 7 is my, M-Y space good, my good, so that's that. So then we do the length of this, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So did I get that right? But I mean, really, it's just 12 plus 7, so that's 19. So the length of that is 19. So this whole thing is 19. 19 modulus 2 gives you a remainder 1. So it goes in, what, 9 times with a remainder 1. 2 times 9 is 18 with a remainder 1. So the length is 1, so that's not correct, okay? Then we do 2 to 8, which is... what are we joining? Okay, so Y 2 to 8 is space good space, and then we join 2 to 9, which would be Y space good space O, and we want the length of that, so it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That length is 15. That's an odd number, not an even number. So the answer must be D, but let's check it. So 3 to 7 is blank good. Blank good. And then 1 and 2 are just my. So we join those together. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Did I do that right? 1 and 2. And then... Oh, wait. What am I talking about? I did 3 to 7. That needs to be 3 to 10. So let's fix this. Three to 10 is blank, good, blank, blank, OP. And then 1 and 2 is MY. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is an even number, so that's D. Okay. Sorry about screwing that up. I didn't have a lot of place to write. Okay, so this one should be a bit easier to write this out. So Seth is writing a dialogue engine for an emergency preparedness game. The program relies on multiple operations. So you're concatenating, so that's just like joining from above. Concatenates, it joins two strings to each other, returning the combined string. And upper returns the string in uppercase. Here's a snippet. So yell, fire, and then concat. We pass in yell, and we upper the danger. So we're going to do this first. Remember, you do everything in its innermost parentheses first for order of operations of really anything. So danger is the word fire. And so fire will be uppercased. And then it will concatenate yell and uppercase fire together. So it'd be like, ah. And then F-I-R-E. So are there any that look like that? Fire. Okay, D. Okay. Six. Barry is making a program to process user birthdays. The program uses the following procedure for string slicing. So now don't get this confused. This is just a different substring formula, okay? We saw a way of doing substrings back in question 4, which I went through. This one's going to be a little bit different because this one is going to take the original string. It's going to have a starting position for where you want to substring it out, and it's going to tell you the number of characters. So return a string of strings starting at the start position of length, number, and then the number of numchars. The first letter of the string starts at 1. His program starts with this line of code. User B-Day is on this day. Which of the lines would return the year? Okay. So if I have 03-31-84, then, always do the lines in between when you get a string, and even if you don't need it, put the index position to, sorry, I'm too used to normal Java. I'll probably make a lot of those mistakes. You guys got to remind me of them. 2, 3, 4, 5, 6, 7, 8. Okay, nothing's there. All right, so we want to return just 8, 4. So that's in position 7 and 8. Okay, so all of these pass in the user birthday, so that's good. Because if one didn't pass in, then you could just cross it out. Okay, the start position here is 7, and the length of this is 2, right? So the start position here is 6, so that's not correct. The start position here is 6, and the start position here is 6. So now we've narrowed it down to 3 possible answers. And all you need to know then is the number of characters. 84 is 2 characters. So we have to do this one. This is only one character that would pull out what? Just 4. No, sorry, just 8. What would this one do? There's not 3 characters starting at position 8, so that would probably give you an index out of bounds error, and you'd be hurting because you have an easy question that you'd miss. So cross that off. All right, next up. Seven. Consider the adjacent mystery procedure. What Boolean values are displayed after executing the following 2 program statements? So we display mystery uppercase A, B, C, D, E, F, G. Gets passed into mystery, and then the second line we pass in uppercase race car. So mystery, what it does is it takes the length. So again, write in your sorry, this is like super hard to I wonder if there's like a size. 1, 2, 3, 4, 5, 6. 6 is just over a little bit too much on the G. 6 and 7. Okay. All right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Okay, cool. So there's 7 numbers. So the length that would be 7 right there, and then K would be 1. So repeat until K is N, and then we've got this going on down here. So we've got N. I'm gonna make this larger now because we got N. That looks bad. We got N. Okay, then we got K. And then we got this S, K greater than S, K plus 1. All right, N is 7, K is 1. So this goes back to the last unit on arrays. So K, what's in position 1 for K right here? Position 1 is A. Is A greater than K plus 1 was 1 plus 1 is 2. Is K greater than B? So this kind of gets us into, you need to know a little bit about this. So ASCII table. All right, so the ASCII table, all of the letters and numbers and everything on here have an alphanumeric value. So here's their decimal value. So uppercase A is 65, uppercase B is 66. So is A greater than B? No. As you go down, the uppercases they get larger as the alphabet goes along. Lowercase, all lowercase values for letters are greater than all uppercase letters. But the same is true, like lowercase a is 97, where lowercase z is 122. So this is probably something that you just kind of need to keep in the back of your head. So is A greater than B? That's not true. So this if statement does not get hit. And then we go to else. So we do K plus 1. So k is 1, so 1 plus 1 is 2. We go back up, n is 7, k is, now 2. Is 2 equal to 7? No. So then we got to check what's in position 2. Well, what's in position 2 right here is B. And is B greater than 2 plus 1, which is 3? Is B greater than C? No, that's false. So then we add 1 here. And then go back up. Is 3 equal to 7? No. So then we look in to see what's in position 3. That's C. And then 3 plus 1 is 4. What's in position 4? It's D. Is C greater than D? No. So we have to do 4 right there, because 3 plus 1 is 4. We go back up. Is 4 equal to 7? No. So what's in position 4? It's D. And then what's in position basically 5? It's E. We add 1 is 5 equal to 7? No. So what's in position 5? It's E. What's in position 6 is F. So we add 1, makes it 6. Is 6 equal to 7? No. So what's in position 6? It's F. And what's in position 6 plus 1 is 7 is what? G. Is 7 greater than, or is F greater than G? No. So that becomes 7. Is 7 equal to 7? Yes. So then we return true. So for this first one, we return true. So so D and C start with false, so we know that's not right. So then we've got to run, so that one's done. We got to run this one. So for this one, I mean, we can just do one of them, right? Is R greater than A? So when you go through here, is R greater than A? Yeah, that's false. So that's what's returned as false. Is R greater than A? That is true, right? But it returns false, because if we go back into here, R is 82 and A is 65. Okay, so that's 80. Yeah. 80. So 82 is greater than 65, so it returns false. So this one returns false. And so true and false. So your answer is B right there for 7. Now, you're not going to have to memorize the numeric values of these letters, but it's probably a good idea that they might ask you a question, and all you're going to have to memorize is lowercase. All lowercases are worth more than uppercases. So if you have to compare a lowercase value to an uppercase, just know that the lowercase values are all worth more. And then it goes from low to high, A to Z. So A is less than Z, Z is greater than A on both of them. Okay, so it's probably something good you got to memorize. All right, 8. Turn to the procedure mystery shown above. Shoot, I should have probably kept that all up, but whatever. Assume that a precondition of calling the procedure is that mystery consists of uppercase letters only. Which of the following describes the purpose of the procedure? So making it uppercase only really doesn't change much of this program. It just makes sure they use uppercase letters. Procedure mystery checks if all characters are uppercase. No, that's not what it returns. B, procedure mystery determines if all the characters in the parameter are alphanumeric characters. No, it doesn't check that. C, procedure mystery determines if the letters of the parameter string are in alphabetical order, ascending. Well, isn't that what we just determined right here? We checked A, B, C, D. That would return true right here. So that was true. And then this one was false because they're not ascending. Ascending's going from A to Z, or 1 to like 100, those are going up. Descending would be the opposite, Z to A, or like 100 down to 1. That would be descending, all right? So don't get those words. You might see ascending. Ascending is like climbing, going up. Descending, you're descending the mountain, you're going down. So C is what you're doing. Let's see D. Procedure mystery determines if the letters of the string are in an alphabetical order, descending order, and it's not doing that. So your answer is 8. Nine. A large data set contains information about all students in colleges across the United States. The data set contains the following information about each student: the gender, the state in which the student attends college, the student's grade point average. So their gender, the state in which the student attends their college, the grade point average, and the student's major. Which of the following questions could be answered by analyzing only information in the data set? Which college has the highest number of female computer science majors? The student's gender, the state in which the student... Okay, so A, it has nothing to do with the college's number of students. It's the specific student, their gender, the state they go to college. So like, let's say you have your student. Her name is, I don't know, Jill. And she goes to college in Colorado. Their GPA is 4.0, and their major is computer science. Okay? Which college has the highest number of female computer science? You can't know that from this information. How many states have computer science as the most common major for female? How many states let's come back to B. Do students attend college in the United States tend to have a higher grade point average than students? There's nothing about other countries in here, so C's gone. D. Which state has the highest graduation rate for computer science? There's nothing about graduation rates. Your answer has to be B, but let's go through it. How many states have computer science majors? So that's that and their major as the most common major for female students. That's hard to figure out. You'd have to do a pretty funky query because you'd have to look at the state and you'd have to look at, well, it's not even that bad. All you do is look at the student's gender. And why did I put in name? I don't know. The student would be like, there would be more information than this. You'd have to have some sort of student ID, all right, or whatever. So it'd be like female, all right? But then you could look and see, and you could compare all the females in here with all their majors, because their major might not be computer science. It could be like, I don't know, math or something like that, okay? So, yeah, B works. B works, okay? Let's see here. 10. Okay, a byte is made up of 8 bits. You have a programming language that uses 1 byte to represent characters and are now modifying your language to use 2 bytes to represent how many more? Okay, so okay, we go back to this, to the 0, to the 1, to the 2, to the 3, to the 4, to the 5, to the 6, to the 7. So there's 8 there, right? So you got what? You got 1, 2, 4, 8, 16, 32, 64, 128. So now you're adding one more on, okay? So that becomes what? 2 to the 8th, 2 to the 9th, 2 to the 10th, 2 to the 11th, to the 12th, to the 13th, to the 14th, to the 15th. So 256, 512, 1024, 248, 4096. This is 8,192. This right here is going to be, sorry, I figured this all out beforehand. 16,384. And this one is what? 32,768. So we want to jump from 8 bits that can hold, you know, this, and how much bigger is that? So your answer is 2 to the 8. That's how many times. But if you do 2 to the 8th, that is 3,200,768. No. That's not right. So 2 to the 8th is 256 times, we're adding on one more of these, right? 1 to the 7th, which is 127. That will be equal to that right there. So if we end up, if that's what we have originally, right? And then we want to double that, it's not really a doubling, it's taking what we had here, right there, right? And then we are multiplying it by 2 to the 8th power. And that's our, that's our check, because I went through all of these to make sure that, 2 to the 8 times 2 to the 7, that gives us that, 2 to the 15th. So I know that that mathematically is correct. Okay, if I did 128 times 8, I would not come up with this number. If I did 8 to the 2nd times 128, I would not come up with this number. If I did 128 times 2, I would not come up with that number, all right? So if you just double the number of bytes, you're not just doubling this number right here, all right, for a byte. You are doing 2 to the 8th power. Okay, so mathematically you have to kind of think through how to do this, all right? And so you're not going to be able to have a calculator on the AP test, so you might not be able to figure out these last 3, but you should be able to see that, these numbers, even if you did this times 8, like let's say you're really bad at math, and you have this question right here, 128 times 8, let's say you're really bad at math and you just get rid of the 28, that's like 800. That's nowhere close to these numbers that we're coming up down here, okay? Times 2, that would be 256. You should be able to do that in your head, right? So you would know, like, these two aren't working. This one might be kind of appealing because you got 8 times 8 is 64. I mean, again, let's say you're bad at math and you do 100 times 64. Well, that's what? That. And you know that these numbers are doubling, so that would be doubling to like 8,000. That would be doubling to 16,000. You know that these numbers right here are much bigger than that right there. So you can kind of figure out these even if you're awful at math, but you guys are all probably pretty good. So anyway, I've got the answers down here. But make sure you guys practice this and know how to figure out all these questions. But I think this video does a good job explaining how everything's done. So this video is